We'll make it fly.
Let's make a rocket.
In order for our toy to be acceptable, it needs to follow a few constraints. First, it has to be 3D printed, needs to run the length of 2.5 meters horizontally, or in our situation, needs to fly up 20 feet vertically. And also has to fit within a 10 centimeter tall egg disassembled, and once assembled, needs to be larger than the egg. Our idea is to build a baking soda and vinegar rocket. In order for it to be successful, the mass of the rocket should be minimized, whereas the internal volume of it should be maximized.
The first rocket was a 2-segment design that when fully assembled was 13 centimeters tall. The purpose of the rocket was a proof of concept and to test the 3D printer to see if we could print threads.
For a potential energy source, our team is using a chemical reaction, using some of the most common household items. The reaction is going to be between baking soda, NaHCO3, and acetic acid. Acetic acid's chemical formula is CH3COOH. The reaction is going to result in H2CO3, which will break down CO2 and water. The CO2 gas will actually create pressure that will pop the cork, creating initial force for the rocket to fly.
Unfortunately, Rocket Mark 1 was leaky, too small, and it used the space inside the egg poorly. We did find out that the 3D printer could correct. With this knowledge, we could move forward with the development of a second rocket. We settled on a 4-segment design that fits efficiently in the egg for an assembled height of nearly 30 centimeters. After receiving our rocket and fine-tuning it for some time, we managed to create a good seal and did some trials, hoping to perfect our chemical ratios. During our third trial, disaster struck. We installed the cork too tightly and built up pressure in the rocket, blew the top right off. This mishap allowed us to make some adjustments to the rocket, including reinforcement of the threads, fins to stand the rocket up, and a crumpling nose section for safety.